So let's see this question. Length of later sectum of the parabola. Focus is given, directrix is given. How to approach with the concept that we have learned? Directrix is given. So let's say this is directrix. This is 3x minus 4y minus 2 is equal to 0. Focus is given 3, 3. Okay, I need to find later sectum. What would be the strategy? Anyone? This is the parabola, right? This is axis. I know focus, this point I know, and I know directrix. This is A units, this is A units. Answer is 4A, which is easy to calculate. I can always calculate distance from S to F, right? What is distance between focus to foot of directrix? Focus to foot of directrix, what is the distance? 2A, correct? This is 2A. So I can calculate distance between point and line if point and line are given. So let's calculate this distance, which will give me 2A value. What is later sectum? This is another 2A, this is another 2A. Length of later sectum will be 4A. 4A would be our answer. S to F distance, that is 2A. Calculate S to F distance. This is the point. Point and line is given. Calculate this distance. Point is 3, 3. Line is 3x minus 4y minus 2 is equal to 0. So substitute point in the line expression. 3, 3 is 9, minus 4, 3 is 12, minus 2 divided by root of x quotient square plus y quotient square. So 2A is coming out as 9 minus 12, how much it is? Minus 3, mod minus 3 minus 2, mod minus 5 divided by 5, which is 1. So later sectum length, that is 4A, which is double of 2A, which is 2. All right, so this would be our answer. Did you understand this? What is distance between focus and vertex? That is A. Distance between vertex and foot of directrix, V and F, that is also A. Okay, distance between focus and foot of directrix, that is 2A, semi-later sectum. Okay, see how nice it is, no? This distance, this is also 2A. This distance is also 2A. All right, this is also 2A. And this distance, this is also 2A. These three distances are 2A only. Okay, SC1, SC2, SF, all these distances 2A, right? Okay, immediately when I say this, what idea you should get? Okay, just one small point. S2, foot of the directrix. This is vertex. A, this is A, this is F. S2 E1 also 2A. Okay, so something like this is there. S2 E1 distance, S2 E2 distance, S2 F distance, all are 2A only. Then immediately what idea will get? Won't you feel like this? Take this as center with 2A as radius. In childhood we have done, no? One fixed end of the compass we keep on S. With 2A as radius we draw a circle. Definitely that will pass through what? E1, F and E2. Okay. Draw a circle with S as center and 2A as radius. That circle will pass through E1, E2 and F. Okay. Right, like this. Okay. So this idea we should get definitely, because 2A, some interesting thing we are observing. Okay. That means what? Circle drawn with later sectum as circle drawn with focus as center, or you can say later sectum as diameter. Touches what? Touches. What is it touching? What is the circle touching? Directrix. Right? This is one slight observation, because the distances S2E1 to A, S2F to A, S2E2 also to A. All right. An equilateral triangle is inscribed in the parabola such that one vertex of this triangle coincides with the vertex of the parabola. Okay. Y square is equal to 4x, one parabola is there. What is vertex of the parabola? What is vertex of this parabola? Directrix is x plus a is equal to 0. Focus is a comma 0. Foot of the directrix is minus a comma 0. Vertex
0,
0 comma 0. Whenever they say vertex of the parabola, it is nothing but where parabola is getting intersected by the line of symmetry. Okay. We have an equilateral triangle inscribed. Equilateral triangle, we are putting it inside the parabola such that one vertex of equilateral triangle coincides with the vertex. One vertex of equilateral triangle is this. So equilateral triangle must be like this. Parabola is a symmetrical figure, so when you insert an equilateral triangle, it must also be symmetrical. Okay, something like this. So let's say this is the equilateral triangle. All right. So we have a situation like this. This is VAB, let's say. VAB is an equilateral triangle. Then find side length of this triangle. How to find side length? Side length means what? AB, no? AB length we have to find. Okay. So when you see this side length, let me call side length as some L. Side length of the equilateral triangle. This angle is how much? Total angle 60. That means this is 30 degrees. So that means this distance will be what? What would be this distance? That is L cos 30. Horizontal component. This is vertical component. L sin 30. Okay, that means A coordinates will be what? L cos 30 we have to move right and L sin 30 above. So coordinates of A would be L cos 30 comma L sin 30 degrees. That means it is L into root 3 by 2, root 3 L by 2, comma L sin 30 means L by 2. But A is a point on the parabola, right? Okay, this lies on y square is equal to 4x. That implies y coordinate, if you square, that is 4a times x coordinate, root 3, like this. So this is L square by 4 is equal to 4a, 2 ones, 2 2s you can cancel. So this is 2 root 3 AL. Cancel L. So what is L? 8 root 3a. So what is length of the equilateral triangle? Length of side of the equilateral triangle? 8 root 3a. Understood logic to this question? Right. If you quickly respond, I can quickly move to next question.
Yes, sir.
This is another question. From what we have studied, with that theory we can do. Focus is given, vertex is given, then find equation of the parabola. Okay, there is one parabola, it seems. It's vertex and focus given. Vertex is 3 comma 3. Focus is minus 3 comma 3. Okay. All right. Now I need equation of the parabola. To find equation of the parabola, what are the two things which are required? See, equation of parabola means we need two things. Okay, first thing is what? Focus. Okay, focus I already have. Second thing I need is directrix. If I know focus and directrix, that form is there, right? First form, x minus alpha square plus y minus beta square is equal to, that one we can use. All right. Now, how to get directrix equation? How to get directrix equation? Okay, what is this line, by the way? This line joining vertex and focus. What is that line? For the parabola, it will be
Axis.
axis. Right? Why am I drawing like this? This is vertex and this is focus. The line joining vertex and focus, that is axis. Okay. What about getting foot of the directrix? Okay, fine. This is fine. Foot of the directrix will be here, no? This distance is A. This distance will also be A. How to get foot of the directrix? My idea is simple. First, I get foot of the directrix. Then I'll find a line perpendicular to axis and passing through foot of directrix. This would be my directrix. Once I get directrix equation, focus I know already. So I can easily find parabola equation. Yeah. What would be F coordinates? I know this is, what do I know? That vertex divides foot of directrix and focus in ratio 1:1, right? Midpoint. So you take it as alpha comma beta, apply midpoint formula, find alpha and beta. Can I write directly what is alpha beta? Okay. So actually this is alpha minus 3/2 comma beta. For this two, I'm applying midpoint formula. Beta plus 3/2. So when I compare, I get beta as 3 and alpha as 9. Okay. Okay. What is equation of axis? What would be equation of axis, or what is the equation of axis? Straight away by looking you can tell what is axis equation. Axis is line, no? Yeah. What is equation of axis? Everywhere you observe for all the points on the axis, y is equal to 3. That means it's a horizontal line. So what would be equation of directrix? It should be a vertical line. So its equation will be x equal to constant. So it should be x equal to what? X equal to what? 9. X equal to 9. Because x coordinate of focus is 9. So you got focus, which is minus 3 comma 3. Directrix, which is x is equal to 9, or x minus 9 is equal to 0. So what is the equation of the parabola? X minus x coordinate of focus square plus y minus y coordinate of focus square is equal to directrix expression whole square divided by root of, sorry, root is not there, divided by x quotient square, y quotient square. So that would be our answer. We'll simplify it and we'll get answer in this form, right? In one of the options form. Okay. That is one thing. That is another problem. Okay. Focus is given, vertex is given. That means you can get foot of the directrix using section formula or midpoint formula. You know axis equation we know. Line perpendicular to axis passing through foot of the directrix. That will be directrix. So directrix equation we are finding. Once focus and directrix are known, equation of parabola we can easily write. Locus of point of trisection of all the double ordinates of the parabola y square is equal to Lx. Can you tell me for y square is equal to Lx, what is latest rectum? Y square is equal to Lx parabola. What will be latest rectum? Length of latest rectum. See, y square is equal to 4x parabola. 4a is length of latest rectum. Y square is equal to Lx parabola. L is length of latest rectum. Correct? What is latest rectum length for this parabola? What is length of latest rectum here?
4/3.
4/3. For this parabola, what is distance between focus and foot of directrix? Distance between focus and foot of directrix means it is 2a. This is latest rectum, right? 2a is half of latest rectum. What is distance between vertex and foot of the directrix? Imagine in your mind, vertex and foot of the directrix. Distance is a. That means it is half of semi-later sectum. That is 1/3. All right. Okay. The locus of point of trisection of all double ordinates of the parabola. Okay. What is point of trisection? Suppose if AB is there, P and Q, they are called points of trisection if P and Q divides the ratio. Suppose I cut this line segment AB at 2 points P and Q, such that AP length, PQ length, QB length same. I get 3 equal line segments after cutting. Then I'll say P and Q are points of trisection. Okay. And now you tell me P divides AB in which ratio? P is a point of trisection. P and Q are points of trisection means P and Q divide AB in the ratio 1:2 and 2:1 respectively. This is one part, this is two parts, this is two part, and this is one part. Q divides AB in the ratio 2:1, P divides AB in the ratio 1:2. All right. So we understand points of trisection. Now what I have to do? Locus of the point of intersection of all double ordinates I have to find. So there is this parabola, y square is equal to Lx. So now I have a locus problem. Locus of what? Point of trisection. Okay, let's say this is point of trisection. I need to find its locus. So I'll take it as h comma k. Where this chord is not, this is double ordinate. So locus of which point? Locus of that point, which is point of trisection of a double ordinate. So this is double ordinate. All right. Now, here another point of trisection is there. Okay. Let's say this. What is this length? What is this length, sir? What is this length? This is axis, right? Y is equal to 0. Vertex is 0, 0. Y square is equal to 4x. Now you tell me what is this distance? It's quite easy for you. How do you reach point P from origin? You have to move h units right, and how many units above? K units above. Okay. Suppose if P is one point of trisection, Q is another point of trisection, no? They should be symmetrical or not? Yes. So Q coordinates would be h comma minus k. That means to reach Q, you travel h units right and k units below from origin. That means what is PQ distance now? What is PQ distance? That is 2k. If PQ distance is 2k, suppose we have a situation like this. I am saying P and Q are points of trisection. This is 2k. Then what should be AB distance and QB distance? AB should also be 2k. QB should also be 2k. That means what is this length? AP. AP should be how much? 2k, right? QB also should be 2k. That means what would be A coordinates now? A coordinates.
H comma 3k.
H comma 3k. But A should lie on the parabola, right? That means y coordinate square is equal to L into x coordinate, that is h. So that means 9, replace h comma k with x comma y to get locus Lx. That means what is y square? L by 9x. So what did I understand just now? These points of trisection, no? These points of trisection, if I have different double ordinates, I have different double ordinates. I collect their points of trisection. They also lie in one parabola. This is what I have understood. Okay. Many double ordinates are there. For each double ordinate, points of trisection are there. If I collect all the points of trisection, again, what I'm getting? What is the locus? That is also parabola. For this parabola, mouth is L. For this parabola, mouth means later sectum. What is later sectum here? L by 9. Okay, so we have parabola like this. Collection of points of trisection, that is this one, right? This is the parabola where formed by collecting points of trisection of this particular parabola. For this parabola, later sectum length is L by 9. Okay, I hope you understood this. Let's see this, what they're asking. Locus of points of trisection of points. You have to collect points of trisection of all double ordinates of this parabola. If you collect that, we are getting the locus as y square is equal to L by 9x. So locus is a parabola. Yes, of course, locus is a parabola. What is the later sectum of the parabola? Locus is one parabola, right? This one. What is later sectum for this? Equation is y square is equal to L by 9x. So later sectum should be L by 9. So we have to mark L by 9.